Every system we've talked about, RAG, memory, and many agents or recommendation engines, has a hidden ingredient. When the system finds the relevant document, or looks up similar memories, or recommends a similar product, something has to define what similar means, that something is embeddings. Here's the trick, and it's beautiful in how simple it sounds. Take a piece of text, run it through a model that's been trained for this purpose. Sometimes the same model that does generation, sometimes a smaller specialized one. The model produces a list of numbers. A long list, usually hundreds or thousands of numbers. That list is the embedding. Now do the same thing for another piece of text. You get another list of numbers. Here's the magic. If the two pieces of text mean similar things, their lists of numbers will be close to each other. If they mean very different things, the lists will be far apart. The cat sat on the mat, and a feline rested on the rug. Different words, but their embeddings end up close together, because they mean roughly the same thing. The cat sat on the mat, and the stock market closed lower today. Far apart. Different meanings, different vectors. So embeddings turn meaning into geometry. Each piece of text becomes a position in a high-dimensional space. Similar meanings end up near each other. Different meanings end up far apart. And the model learned this layout from the training data. Same way it learned everything else. Now watch how this powers everything you've already learned about RAG. When a question comes in, the system embeds the question, turns it into a vector. Then it compares that vector against embeddings of every chunk in its corpus. The closest matches are the most likely to be relevant. The system retrieves them and pastes them into the prompt. That's what RAG retrieval actually is, vector comparison. Memory, same idea. Stored memories are embedded, new queries are embedded. The product looks up which stored memories are nearest in vector space and pastes those in. Recommendation systems, songs, videos, products, all embedded. When you watched a video, the system finds nearby vectors and recommends those. Search. Modern search often combines old-school keyword matching with embedding-based semantic search. Your query can become a vector, documents can become vectors, and the system can find results that match what you meant, not just the exact words you typed. Image similarity. The same trick works on images. An image embedding model turns a picture into a vector. Find the nearest vectors, find similar pictures. Across text, audio, images, video, same underlying move. Convert content into a vector. Compare, find closest. A few things to know. Embedding quality matters. A bad embedding model puts unrelated things close together. There are leaderboards for this. Embeddings have biases. The model learned similarity from training data, and training data reflects whatever was in it. So, embeddings can encode gender, race, and profession associations. Real systems have to handle this. Embeddings need a place to live. Storing and searching billions of vectors is its own engineering problem. That's where vector databases come in. Different conversation, but you've now seen the seed of why they exist. So here's the picture. The model generates. The corpus stores text. RAG retrieves chunks. Memory stores facts. Agents loop through actions. And under all of it, embeddings define what similar means by turning meaning into position in space. To recap, embeddings are lists of numbers that represent meaning. Similar meanings produce nearby vectors. Different meanings produce distant vectors. RAG, memory, search, recommendations all use the same vector comparison trick. That's the playlist. You now know how a model predicts text, how it learned by guessing, how it holds a conversation, why it hallucinates, how memory and RAG paste in real information, how to talk to it well, how agents put it in a loop, and how embeddings let any of this find what's relevant. That's not all of AI, but it is the bedrock for understanding modern AI products. From here, every more advanced topic is a variation on these themes. Thanks for watching the playlist. If this was useful, subscribe. It tells me to keep making them. See you next episode.